Assalamu alaikum students, this is Hamza Noor and today we have some questions from the topic S1 normal distribution, and the questions are from the most recent attempt May-June 2020 paper 5-2 question number 4, and then we have another one May-June 2020 paper 5-1 question number 6. So let's see how these questions are done. The first question says that trees in the radian forest are classified as tall, medium, or short according to their height. The heights can be modeled by a normal distribution with mean 40 meter and a standard deviation 12 meter. Trees with a height of less than 25 meter are classified as short. Okay. Find the probability that a randomly chosen tree is classified as short. So basically we are having three types of trees: tall, medium, and short. And what we know is X is distributed normally with mean 40 meters and the variance would be 12 squared. This is how you write uh, notation for the normal distribution basically. Okay, the standard deviation is given 12, but you have to write it like this: X is distributed normally with mean mu and variance sigma squared. Now what do you need to find? uh, and you also know that trees with a height of less than 25 meter means probability of X is less than 25 meter would be classified as short. You need to find this probability that X is less than 25. Okay, so all you need to do is just standardize this. So if we standardize this, we will get probability of Z is less than 25 minus 40 divided by the standard deviation. 25 minus mu divided by sigma divided by 12. So this is probability of Z is less than 25 minus 40 divided by 12. This is how much? Minus 1.25. Okay. All right. So the next thing is you need to make a sketch. Always recommended, always helpful to make a sketch. Okay. And since you know that the Z value is -1, and you want to find out this probability basically, probability of Z less than minus 1.25. But the thing is, if we look up at our normal distribution table, if we do a normal lookup, we know that all of the Z values are positive over there. So what I'm going to do is make an exactly symmetrical graph over here and put the value 1.25, and obviously my requirement would be this, isn't it? But here again one problem arises more. All of the probabilities given in the Z distribution table are greater than 0.5. Okay, and one more thing, whenever you find a probability of any Z value, you will get this: Z is less than Z. Z is less than a certain number. But here we want the probability of greater than Z, which is a minor region. This is basically a minor area which is less than 0.5. So what I'm going to do is I'm going to find probability of Z is less than 1.25. So I will be getting this area, this one. When I will get this area, I will subtract it from 1, since sum of all the probabilities is equal to 1, area under the graph will be equal to 1. Alright, so let's take a look at our normal distribution table. Z less than 1.25. 1.2 is over here, okay, and 1.25 over here. So coming right over here, 0.8944. So this area is 0.8944. So what I'm going to do is I will subtract it from 1. 1 minus 0.8944, and therefore my final answer would be 0.1056, and correct to three significant figures you will write it 0.106. Alright, this is how part number A is done. Let's come on to part number B. Part number B is saying that of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. show that the probability that a randomly chosen tree is classified as tall is 0.298, correct to 3 decimal places. Okay, one thing you know that from this part, that probability that x is less than 25, probability that x being less than 25 you have just calculated, which is 0.106. And this is basically the probability that a tree is short. So how many total possibilities do we have? We have short, tall, and medium. So if I do 1 minus 0.106, I'll be getting the probability of the tall the tall trees and the medium trees altogether. 1 minus 0.106 is how much? 0.894. This is the probability of total tall and medium trees. And since the question says that one third are tall and two thirds are medium. So if you multiply 0.894 by one third, multiply by 1 over 3, you will be getting the probability of that a randomly chosen tree is classified as tall. So 0.894 multiplied by 1 over 3 gives you 0.298 exactly. Correct to 3 decimal places. This is your requirement. Okay, what would be the probability of being medium? Definitely multiply by 2 over 3. 0.894 multiplied by 2 over 3. This is how much? This is 0.596, but this is not your requirement. Just to let you know that this is 0.596. So 0.596 plus 0.298 plus 0.106, which you found in the earlier part, altogether they will give you, let me add, let me just add all of them. This will give you a probability of equal to 1. Alright, so 0.298 is your answer, is your requirement, that the probability that a randomly chosen tree is classified as tall. Let's come on to the next question. Okay, the last part is left. Part C is saying that find the height above which the trees are classified as tall. You don't know the height basically. For example, that height is classified as h. Above, we want probability x greater than h. And but we know that probability of being tall, a tree being tall is how much? 0.298. Okay. And since we know that our normal distribution, x is normally distributed with mean how much? 40 and variance 12 squared. Okay. So if we just standardize this, probability of z is greater than h minus 40 divided by the standard deviation divided by 12. And this probability is basically equal to 0.298. Here we need to do a reverse lookup. We are given the probability, we need to find the corresponding z value. But the thing is, one problem arises over here, that when we go to find the reverse lookup, to do a reverse lookup in the z normal distribution table, what we see is all of the probabilities are greater than 0.5, greater than equal to 0.5. So what I will do is, first I'll make a sketch. Always recommended, always helpful to make a sketch. जिंदगी आसान हो जाएगी आपकी. 0.298. Okay, I want probability of z greater than a certain value. So this is that certain value basically. This is the z value. Okay, I want the probability being greater than this. And since the region after the z value is a minor one, means it is less than 0.5. So this is definitely 0.298. So I can say that my z value would be definitely positive. I know now that my z value is definitely positive. So what I'm going to do is I'm going to do 1 minus 0.298. Okay, because the issue is that when you do the reverse lookup, all of the probabilities are greater than equal to 0.5. So 1 minus 0.298 is how much? This is 0.702. 0.702. So I know that this region basically is 0.702. So what I'm going to do is find the reverse of 0.702. Let's see how it is done. We need to find the reverse of 0.702. This is the probability. We need to find the corresponding z value basically. Well, let's come on to your normal distribution table. 0.702, where it is lying, uh, 0.7019 is over here. Okay, so the value corresponding to this is 0.53. 0.53. I mean, it is the most nearest value to 0.72, isn't it? 702 basically. 0.702. It is the most nearest value to 0.702. All right. Or one more thing, if you add three digits to it, so you will be getting 0.531. I mean, you can take both of the values, but the most accurate one is this one, because this is uh, nearly to 0.7019 as compared to adding a 3 afterwards. I mean, बात समझ आ रही है? बहरहाल. So this is 0.7019, and the z value is 0.53 basically. It is positive. So 0.53 is the value of z. So now we are able to find the z value. So h minus 40 over 12 is equal to 0.53. So 12 multiplied by 0.53 and add 40 to it. Your answer is 46.36, and correct two three significant figures. Your height is 46.4. 46.4 meters, because the original information in the question is given in meters.